So I thought I might do a quick graphics display calculator skills video for the one of the quizzes we did, where you had to do a little bit of graphing using your GDC based upon a particular context. It's really important to understand the context, and it's really important how to use your graphics display calculator to solve the problems. Now, that's the function there, and it says it's a water fountain's water stream fits the following function as follows. X is the distance of the water stream, is the distance the water stream is away from the spout of the water fountain. And h of x is the height of the water stream above the ground. And then you ask questions. So first thing which I covered in class was use your GDC to graph the function showing all intercepts and turning point. Now, when I've already put this into our calculator, if I go Control G and go up, you'll see there it is there, minus 0.6, blah, blah, blah. So that's fine. It's actually fitting quite nicely into this graph here, so I don't think I'll change the view. But when it says all intercepts and turning point, that means that value and that value, the turning point here, it does not mean this one. And I talked about this in class. As you can see, when I graphed it from here all the way down to here, and I didn't graph the rest. And that's because the rest of it does not make sense in the context of the question. The water is going to start from the spout here, and it's going to go up, and then it's going to go down and hit the ground here. Okay, so that's all you have to draw. In fact, you shouldn't draw anymore. If you do draw it, just either do a cross line through it as well to show this is not relevant, or do hash marks all the way through like so. That's the actual drawing of it itself. Just a reminder about how to get all of these points. First things first, if I go to the menu button and go Analyze Graph, we've got zeros and maximums that we can use for the features we're looking for. So click on 0, left click to the left of that x-intercept here, right click here. I can drag this so I can see it a bit more clearly. It's 4.09 meters, and you can see I've got that written there. If I want to get the y-intercept, typically when I go menu trace and then do a graph trace, it normally zeroes in on the y-intercept to start with, and you've got f1 colon here, 0, 4.14. So then I can go and type in 4.14 there, like I've done. And then the maximum is menu, analyze graph, maximum. Obviously, if this graph was the other way around, I would go to minimum. And there it is there, 1.2, 5, which is what I've written in up here. Then there comes the interpretation of this. How high is the spout above the ground? And of course, this is a maximization problem. There's the curve there. I'm going to put the maximum value in, and you type in 5. But wait a minute, my answer is 4.14. Why is that? It's because I didn't ask how high the water was above the ground. I asked how high the spout was above the ground. And if the water's coming from the spout, then the y-intercept is effectively the height of the spout above the ground, hence 4.14. Secondly, how far away from the spout does the water stream hit the ground? Well, the water starts here above the ground and then goes up in an arc and down and hits the ground at 4.09. So it is the x-intercept for the answer here, 4.09. Next question, what is the maximum height of the water stream? Now that we're talking about the maximum and the water stream, now we can look at our our turning point and decide, do I want 1.2 or do I want 5? Well, 1.2 would be how far away from the spout the maximum is. We asked for the maximum height, so it would be 5 meters, the y value. Some people put a coordinate in here, but I didn't say give me the coordinates. I said, what is the maximum height? So you should be working out exactly what the context of the question is. What is the maximum height? The height is 5 meters because everything is in meters here. The next one is how high is the water stream when it is 2 meters away from the spout? So that's 2 meters away would be, what is the value of y when x equals 2? Okay, so what we are going to do is we are going to work out what that value is by using our graph. I'm going to go to Menu, Trace, and then Graph Trace. Now what I could do is I could keep on pressing the arrow until I get to 2 meters, and nope, it went past it. Did you see that? So 2 meters, it goes from 1.8 to 2.1 and so on. Now there's a few ways you can fix that, but probably the easiest thing to do is in fact go straight to typing it in on your keyboard. Doesn't matter where it is at the moment. Hit 2 on your keyboard and look, it has x equals 2 that appears here. And when I press enter, it jumps to 2, and down here it gives you the coordinate 2, 4.62. Now we're interested in the y value. So when x equals 2, when it's 2 meters away from the spout, y equals 4.62. So that's 4.62. And the last one is how far away from the spout is the water stream. So how far away? So this way, when it is 4.5 meters high from the ground. So there's 4.62. Now again, you could technically use the trace to try and work out where 4.5 is, but it's likely to go over. And you can adjust the trace so that it does go through there, go through the points quite clearly at 4.5, but I've got a better way of doing it. And what we're going to do is we're going to introduce a new graph. And this graph, f2 of x, is going to be, f2 of x is the value we are looking for, 4.5. Press enter. And then this red line here cuts through the blue line at 4.5. So the intersection there and the intersection there will give us the two values we're looking for. Note that it's 2. Many of you just wrote down one value, but the water goes up and hits 4.2, 4.5 meters, and then continues to go up, and then it falls down again, and then it will be 4.5 meters a second time before hitting the ground. Now, if it said, what is the how far away from the spout is the water stream when it is first 4.5 meters away from the ground, then you could get away with just the 1 point. But it doesn't say that, so you need both. So once you've got that second line in, we're going to go to Menu, we're going to go to Analyze Graph, we're going to go to Intersection this time, we're going to go to the left of the intersection and to the right of the intersection, and there's one of our answers, which I'll shove up here, 0.287, which is roughly 0.29. And then I'm going to repeat the action again on the other side, moving this out of the way so I can read it. There you go, that's good enough. 2.11, 4.5. So my two answers are 0.29 and 2.11 to 2 decimal places. And that's basically how you do the calculator question. So just in summary, make sure that you only draw the part of the graph that is relevant to the context of the question. Make sure you use your graphics display calculator as much as you can in order to solve it. And if it's worth more than 1 mark, make sure you put some working out, whereas these didn't. So if it said how far away from the spout is the water stream, 4.5 meters, I would go 4.5 equals negative 0.6x minus 12 squared plus 5. So I would show that I understand where I have to substitute 4.5 into. And then my next line would be reading it off my calculator screen. For this one here, how high is the water stream when it is 2 meters away from the spout? I would go h of x, or h of 2 if you like, equals negative 0.62 minus 12 all squared plus 5. So I'd do the substitution as my first line, and then my second line would be reading it off the graph to give me the answer. Okay, that's if it's worth more than 1 mark. If it just says write down, or if it's only worth 1 mark, then literally just read it off your calculator and then move on.